Now in this lesson, we are going to start our discussion on atomic structure. Sir J.J. Thomson discovered the electron in 1897. Next year, he gave a model of the atom that is called plum pudding model. He said there is a positively charged sphere and electrons are embedded in this sphere like plums in a pudding. And this was the model of atom given by Sir J.J. Thomson in 1898. Okay, this is what a major scientist thought how an atom looked like in 1898. Then a famous experiment was done by Geiger and Marsden under the advice of Rutherford, that gold foil experiment. They took a very thin gold foil, 1 micrometer thick. We should not be saying thick because that is actually thin, right? But we say 1 micrometer thick. Why they took a gold foil? Not because they liked gold, because gold is malleable. It can be beaten down into thin sheets. And they bombarded this gold foil with alpha particles, which are quite heavy particles compared to electron at least. These alpha particles came from radon gas. Radioactivity was known at that point of time. They found that most of the alpha particles went straight through as if nothing is there. So this model of atom failed, right? If these kind of solid spheres are there, then the electrons, the alpha particles cannot pass through that. Some alpha particles were scattered appreciably. Very few, 1 in 8,000 alpha particles suffered deflection more than 90 degrees. This was very surprising. Rutherford said that this is like you fire a bullet at a tissue paper, it comes back and hits you. This is such a thin metal foil, 1 micrometer thick, rather thin, right? Even then, some alpha particles are turning back. So based on this, Rutherford made some conclusions. First conclusion was that most of the atom is empty space. That's why all the alpha particles, most of the alpha particles are going through, straight through. There is a very small space inside an atom that is called nucleus. Almost the entire mass and all the positive charge of the atom is concentrated in that very small space, and that he called it nucleus. The concept of nucleus was given by Rutherford. Now you have to put the electrons somewhere. Where to put electrons? That idea came from the solar system. Earth is going around the sun, so electrons must be going around the nucleus. And what to do with the electrostatic force? That electrostatic force provides the necessary centripetal force. Right, all of you know circular motion, right? When I think to move in a circle, we need a force towards center, and that is called centripetal force. So this was the concept given by Rutherford. At the center of an atom is a nucleus which is very small, almost all the mass and the entire positive charge is there. Electrons move around the nucleus in circular orbits. Now what were the issues with this model? Why this model had to be replaced? When an electron moves in a circular orbit, it is an accelerated charge. Whenever a charged particle accelerates, it will radiate energy and hence it lose energy, right? It will emit radiation, electromagnetic radiation that we learnt, therefore it lose energy. And therefore, the electron should follow a spiral path and fall into the nucleus. Continuously is losing energy, so kinetic energy will come down and it will follow this kind of spiral path and fall into the nucleus. Right? But an atom is stable. Electrons don't fall into the nucleus. So something is wrong with this model. The other thing that was wrong with this is that as per this model, the emission spectrum of hydrogen should be continuous because continuous radiation is coming out. But people knew the emission spectrum of hydrogen and that was discrete. It's got certain wavelengths that are emitted. That cannot be explained by using Rutherford's model. So that was the drawback of Rutherford's model. First thing, electron moving in a circular orbit is an accelerated charge, which according to classical electromagnetic theory must continuously emit radiation and hence lose energy. Therefore, the electron should follow a spiral path and fall into the nucleus. And secondly, this model could not explain the emission spectrum of hydrogen. Now in the next lesson, we are going to learn about Bohr hydrogen atom. Bohr was actually a student of Rutherford and he gave his model of the hydrogen atom in 1913. Rutherford gave his model in 1911. Right?